Question from October November 21, 9709, variant 33. Question number 6. A part. By first expanding cos of x minus 60 degrees, show that the expression 2 cos x minus 60 degrees plus cos of x can be written in the form r cos of x minus alpha, where r is greater than 0 and alpha is greater than or greater than 0, at the same time less than 90 degrees, between 0 and 90 degrees. Give the exact value of r and the value of alpha corrected to decimal places. Now for this solution, we start with the expansion of cos of x minus 60 degrees. So the expansion of cos of x minus 60 degrees. Here I can give the formula. So the formula is cos of a. So this formula I can explain like this. Cos of a. So we have cos of a. If it is cos of a plus b, the formula is cos of b, upper sine minus sine of a sine of b. If it is cos of a minus b, then the formula is cos of b plus, so opposite sign. So cos of a minus b is cos of b plus sine of a sine of b. So this formula you can apply here, cos of a minus b. So this is a and this is b. So we have a and b here. Cos of a cos of b means cos x cos 60 and plus sign opposite. For cos, the sign is, if negative is in the bracket, we write plus sign. Sine x sine 60 degrees. You can use the value cos of 60 degrees is 1 over 2 cos of x plus sine of 60 degree is root 3 upon 2 sine of x. You can use calculator for this, or you can write them directly. So these are simple. These are the standard angles, 60 degrees and 6. So cos of 60 is 1 over 2 and sine of 60 is under root 3 over 2. So this is the expansion of cos of x minus 60. Show that this expression can be written in the form which is r cos of x minus alpha. So let us start with this 2 cos of now. Next, 2 cos of x minus 60 degrees plus cos of x is identical to, so 2 is 2. For this we have the expansion in the previous step, half cos of x plus root 3 upon 2 sine of x plus cos x. Opening the brackets, 2 multiplied by 1 over 2 is just cos of x. 2 multiplied by root 3, 2 cancels 2, root 3 over 2. Multiplied by 2 is root 3 sine of x plus cos of x. Like terms, cos of x cos x is 2 cos of x plus root 3 sine of x. So it means that 2 cos of x minus 60 is now in a different expression. So we have the different the alternate expression to this thing. But the required form is entirely different. It is r cos of x minus alpha. So I'm looking for this thing equals to r in the form r cos of x minus alpha, where r is positive and alpha is angle between 0 and 90 degrees. So how to write? So there are two methods. So you can show the detailed working, or there is a shortcut, there's a tip, and you can apply that. And that is that if you have, so just keep in mind these 4 cases. So these 4 cases are the compound angle transformations. So there are 4 cases for the compound angle transformation. So these are the only 4 cases. A sine of x plus b cos of x is r sine of x minus plus alpha. So we have a sine plus b cos a sine minus b cos, the second case, and on the right hand side I'm writing r sine of x. So you can keep different tips in mind that if sine is here, it should be sine on the right hand side. And for the sine, this sign is plus, we have the same signs on both sides. If it is sine here, the first place, so write sine and yes, negative and negative. So r is common in all the cases. The third case is r cos x plus b sine of x. So we have cos, so notice cos is there. So these are the standard forms. So for the cos, we know that the formula for the compound angle identity for cos, if it is plus sign, we have negative sign, we have plus on the opposite sign. For plus, we write negative. For negative, we write plus. So keeping this idea in mind, you can say that uh, for the case uh, of cos, if it is plus sign, write negative on the other. And again, we have cos, write cos. R is common throughout. And x plus alpha, for minus, write plus. So for the sign, this sign, middle sign, is same as the sign which is on the left hand side. For negative, it is negative. But for the cos, we write the different sign, negative for positive and positive for negative. For all these four cases, R can be calculated by using this formula. R equals to square root of a square plus b square, and alpha is tan inverse of b over a. In all the four cases, we have a and b. So these are the two formulas, and using these two formulas, you can find the value of r and alpha. This is a shortcut. So for all the cases, r is a square plus b square under root, and for all the cases, it is tan inverse of b over a, the value of alpha. So I can give the proof for one, and for the rest, you can do the same thing. So let us do the first. A sine plus b cos. The first is a sine plus b cos is equal to r sine of x plus alpha. Here is the working. So on the right hand side, we have sine of a x plus alpha. You can apply the compound angle identities, sine x cos of alpha plus cos of x sine of alpha by using the formula sheet. You can write this formula, and I can give the reference. This formula is here. Next, you can open the bracket, r sine of x cos of alpha. So I'm writing sine of alpha in the end, and then r cos of alpha into sine of x, r sine of alpha into cos of x. In this way, there are two sides, and these two sides are identical. What you can do, you can compare both the sides. You can compare the coefficient of x. The coefficient of x on the left hand side is a, and the coefficient of sine of x on the left hand side is a, and the coefficient of sine of x on the right hand side is r cos of alpha. Just equate. The coefficient of uh, cos of x on the left hand side is b, and on the right hand side it is r sine of alpha. So in this way, there are two equations. You can solve them for the value of alpha and r. So there's a special technique. For the value of alpha, what I can do, I can divide 2 by 1. If we divide 2 by 1 means divide left hand side by left hand side and right by right hand side. So we have r sine of alpha over r sine of alpha over r cos of alpha is equals to b over a. In the same order I'm dividing, r goes with r, and we have tan of alpha equals to b over a. So in this way, you can find the value of alpha tan inverse of b over a. For the value of r, you can square both equations. If you square one, it will be a square equals to r square cos square of alpha. So r square cos square of alpha, and the second r square sine square of alpha if you square the second equation. So after squaring, let us add. Add left side to left side, a square plus b square, and right to the right. So on the right hand side, r square is common, and inside the bracket is cos square of alpha plus sin square of alpha, that is 1. And so in this way, the value of r is a square plus b square, and the same type of working you can apply for the rest of the three cases, and you'll find that the r will be the same for all the cases, a square plus b square under the root, and alpha would be tan inverse of b over a. So just keep in mind these cases, these four cases. So you can't find these transformations in your formula sheet MF19. Just keep in mind this very simple sine, 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 we have sine, cos, we have cos, and cos. So you'll have to first check before applying this transformation whether the case is appropriate or not. And then the adjustment of sign is very simple. Now coming to this question, as you're looking for, so this is number say 1. I'm now starting with this part. Yes, taking only this part. 2 cos x root 3 sine x is identical to, this was the requirement, cos of x minus alpha. Yes, this is one of the cases. So we have cos here, we have cos here, plus sine, and we have minus sine. So this is matching, this is matching 2 cos plus, this is matching actually this part. A cos plus b sine is or cos of x minus alpha. So simply, if the case is matching, then identify the value of a and the value of b. So this is a and this is b. So a and b. So carefully decide a and b. So a is equals to 2 and b is equal to, here a equals to 2 and b equals to 3. And the formula for r we know is a square plus b square under the root, a square plus b square under the root, r is equals to 2 square plus root 3 square. So in this way, the value of r is equals to root 7. So r is root 7, and the formula for alpha was, remember, this was tan inverse of b over a, tan inverse of b over a. So tan inverse b upon a. So better to apply this shortcut. So this would be a tan inverse of b, we have decided. So alpha would be in this. So alpha is equals to tan inverse of b over a as square root of 3 divided by 2. So inverse tan of root 3 over 2 is coming as 40.8933, so on. So the answer is required for alpha. Correct to significant figure. Yes, we have the value of, we have obtained the value of r, and yes, the value of alpha. The question was to find alpha correct to 2 decimal places. So after this working, we have the answer. So we have obtained this r as equals to root 7. So we have obtained the value of r as root 7, and alpha we have obtained as 40.89. And so this given expression can be written. So 2 cos of, finally I'm writing the answer. Therefore, 2 cos of x minus 60 plus cos of x. So initially it was equals to 2 cos of x plus root 3, and this can be written in this form, which is r cos of x minus alpha, and this working is there for the value of r and the value of alpha. So after this working, you can write the answer that this thing is equals to root 3 cos of, so root 7 cos of x minus 40.89. So this is actually a different form of the same expression which was given. Here is the solution. So stepwise, first I expanded this, then I wrote another form of this, and this form can be written in a special form, which is our cos of x minus alpha, and this was the requirement. And after confirming whether the case is appropriate or not, identify the value of a and the b value, and after a and b, simply write the direct formulas for r and alpha, and so we have the answer for the part A. Second part is hence. Hence means you'll have to get it from the previous part. Hence find the value of x in the interval 0 to 360, in the interval from 0 to 360, for which the same expression 2 cos x minus 60 plus cos of x takes its least possible value. So I'm looking for the least possible value. So of this thing, 2 cos 2 cos of x minus 60 plus cos of x is equals to root 7 cos of x minus 40.89 degrees. So least value, for the least value of this expression, let us focus here on the right hand side. Just one ratio is, so in the presence of two ratios with a plus sign in between with two different angles, you can't identify the least value. But if you have the alternate expression and this is cos of something, so whatever is the angle, we know the least value of cos. So what is the least value of cos? The least value of cos, if you just recall the graph of the cos, this is the graph of the cos. So at any stage, so the least value will remain -1, the maximum is 1. So if it is on the left, right, again, still the least value will be -1, the greatest value will be. So the least value, for the least value, you'll have to replace for least value cos of x minus 40.89 be equals to -1. So the value root 7 multiplied by -1 minus root 7 will be the value, but that value is not required. So to find the value of x, so from here you can find the value of x. X minus 40.89 is equals to cos inverse of -1. X minus 40.89, just one value is required, equals to 180 degrees. So yes, we have the answer 180 plus, so 180 plus, so this value would be 220.89. But we know that the final answer should be correct too. So here was the requirement to write the answer for alpha to two decimal places, but for this case, for the last case, we followed that instruction which is on the front page of the paper. So all the answers in degree should be given correct to one decimal place. 220.9 degrees is the value of x for which uh, this is least. This is how you can answer this question.